First of all, I want to say thank you to all of the people working on this webinar. It's greatly appreciated, and I welcome all who are attending. For some of you, it's early morning. For some of you, it might be in the afternoon, and for me, right now, it's about 3 o'clock in the morning in the United States. So this is actually quite fun in my mind. I've decided I should stay up so that I didn't oversleep and miss this wonderful opportunity. I do look forward to any questions anytime. If you would be so kind as to just send them via text, that would be great. A little bit of a history. I was the co-chair of the environmentally sound testing, refurbishment, and repair of used electrical and electronic equipment for the PACE working group. And it is a 44-page document that we worked on diligently for 3 or 4 years. And I also want you, each and every one of you, to know if you have questions or want to learn things further, that I would be more than happy to work with each and every one of you, because this process of refurbishment and repair is available worldwide. Just as technology is available worldwide. For the specific document, the guideline, you will find it posted on the Basel Convention webpage, and you will see here that the URL for the document is there. It is in English. I do not believe that the Secretariat has translated it into other languages, and hopefully, well, if you have any questions on that, please feel free to contact me. The document covers measures that refurbishment and repair, and I will a little later on define in some more detail what I mean by refurbishment and repair. But places and people who are responsible for the refurbishment and repair of computers. So this document is a guideline to it in terms of environmentally sound management. So it is part of a process that one should consider when wanting to reuse computers. It's not a complete document. For that, it takes some more work. But again, I'm happy to provide resources to you, and will later on provide some resources to you that you can use and start your own process. Let me just start out with a definition of physical repair. From time to time, it is necessary to physically repair a computing device. You'll notice, by the way, that the PACE, or Partnership for Action on Computing Equipment, specifically refers to IT equipment, or PCs, laptops, and desktops. Though much of the knowledge and processing, though the specifics are different, can be applied to other technologies such as cell phones. So the first thing that's kind of important to understand is repair is a physical process. So when we receive equipment, we want to, in order to reuse it, we want to make sure that it is physically sound, so that if something is broken, you either repair it or you replace a part that is working. Most of the time, in computer refurbishment, a defective part or portion of the computer is not actually repaired, but rather swapped out with a working model. It's important to understand the notion that repair typically is a combining of a set of parts to make a whole device, whereas refurbishment is a logical function. In other words, in the refurbishment process, you are taking and trying to eliminate errors or problems that the logic of the computer will have. So often that is called software. And so an operating system is software, such as Windows 10. And that's necessary if you want to use something like a web browser, which is also another piece of software. I would suggest to you that many, many computers have problems with their software and their hardware works just fine. But to the user, or from the point of view of the user, one would only understand that the computer as a whole doesn't work. So together, both physical device needs to be whole, and the logical device needs to be whole. And so that's why we call it a computer system. It is a combination of both hardware and software. And understanding that at greater and greater detail allows you to reuse computing equipment that has been used by another. And these are the 5 major elements that or tools that we use in order to understand in our process. Manuals that help us understand what the design is and what the appropriate functionality is. Ways to diagnose or test the device, either in whole or in part. Tools that we use to physically repair the device, or even some tools to analyze logically the device. Software, and so a classic example there would be the Windows 10 operating system or an Apple operating system. And then from time to time, you'll need parts in order to make the system whole. Now, what I want to do is, it is my belief that the most value that can come from this exercise is that people begin to reuse computing equipment. And what I've tried to do here is create a very simple way to understand what it is that has good value versus items that have value that is not as good. I simplify it by calling it bad. I don't mean that other than it's not good. So, for example, if you have a computer system, at a very simple level, if you look on the computer or the laptop itself, and you either see a Windows 7 logo, a Windows 8 logo, or a Windows 10 logo, you know that it's worth spending some time to repair it physically and to logically refurbish it. Whereas the Windows XP logo is probably not worth the time and attention that one might spend to bring the computer back to full functionality. And also, fortunately for many of us, is that there is a constant supply of these devices because there are what I call tier 1 users, users who find it worthwhile to get newer equipment on a relatively frequent basis. Now, so just looking at the stickers, one could start to understand what is valuable and what is not so valuable. The goal here is if you have a flow of material that you can start to separate or differentiate the value from, you can start getting some value and then reinvest it into more and greater reuse. If you want to take this to the next level, where there's a little bit more detail, what you would do is yes, you want to look for these stickers, but another clue to what is valuable versus what isn't valuable is that the cases are black and silver versus a beige color or kind of a skin tone. Black and silver are good. And if you want even more detail of what's called a C2D or Core 2 Duo system, an I3 system, an I5 system, and an I7 system. All of these systems would have considerable value beyond sending it off to material recovery going forward. Let's think about this again, but let's think about it at the level of hard drives, or those devices that store our files and records. A good hard drive is one that has, where this green arrow is, this what's called a SATA connection, S-A-T-A, which stands for Serial Attached, I can't remember, S-A-T-A. Ones that are bad is this first one here with the red arrow that's pointing to your right. It's showing that the connectors there are bent, and so they wouldn't be useful. Or these are different kinds of connectors that are not likely to be used in any reuse scenario. There's also one here that has 4 large pins on the right in the lower right-hand corner, and about 60 small pins here. Those kinds of hard drives are bad. I don't mean anything other than probably not worth reusing. If you want to go to the level 2 on the hard drives, what you want to start to look at is the labels on the hard drive, and you get a hint of a label here. And what you're looking for is hard drives that are 80, 120, 160, 250, or even larger hard drives. Those are the ones that are real valuable. And if you find any that have a 1 TB or 2 TB, which sounds for terabytes, that's equal to 4 of these. So it's quite valuable way to look at it. Again, the concept here is what I'm trying to do is if you have a stream of material that you can start to get some value from, and then reinvest that value into more learning and more understanding about how to reuse, that it will be a program that you can build on your own without lots of upfront investment. Let's do the same thing here with memory modules. So there's 2 kinds. There's 2 kinds of good ones. There's a laptop, which is the shorter one, and then there's a desktop. What you want to look for here is memory that has small chips. It's about the size of the end of your pinky, and there are only 8 chips. So those are good, memory modules to find. Bad ones, again, I'm not saying that they're unusable. I'm just saying they're not generally usable, are ones that have 9 chips or larger chips. And kind of one of the things to be thinking about in the world of computer, smaller is better. So smaller chips are good, larger chips aren't. And if we take this same concept and go to level 2 on this, then what we want to talk about is some more detail. So what we want to see on these labels here is we want to be able to see that they have a 1 gigabyte, 2 gigabytes, 4 gigabytes, or 8 gigabytes. And larger is better here, and going forward. So other items of value would be LCD screens, keyboards, mice, solid-state hard drives, laptop chargers, power cords. And I encourage you in your communities to find, if you have a stream of material that is considered waste, to start looking at what value you could extract beyond just the materials and use that as a way to bootstrap or reinvest in in reuse. And you can go beyond that. My goal, quite frankly, is with those last 7 slides, is be able to give anyone and everyone a simple way to look at this technology and start to get get the value that's there. Beyond that, one of the things that you can do is you can become a Microsoft registered refurbisher. There are about 6,500 of them in the world today. It is a free program to join, and it allows you to get genuine licenses from Microsoft that will meet all of the needs so that you can get constantly upgraded. It's as if you bought a new one, but a much discounted price. So there's 2 kinds of licenses. There's citizenship and there's commercial. The citizenships license are about $6, and those are for schools and nonprofits and things like that. It does require a constant flow of material, but certainly it's better to take these materials and rather than just grind them up and try to recover some modicum of precious metals out of it, to reuse it. It is significantly better to reuse an item, or particularly a computing device, because 90% of the energy needed or used in the lifetime of a computer is in the manufacturing or the making of the computer. Repair capabilities. One of the things to remember is that all the computers, as complicated as they seem and as one single piece all melted together, are simply a collection of parts. And they had to put them together, so there is a way to repair them. It's just hopefully being able to find the right information in order to do it properly. And it can be very confusing and very technical. So you may need a technician or someone who is familiar with it as kind of the heart of your refurbisher program if you decide to go beyond just getting parts value. Now, parts values typically are 3 to 4 to 5 times the value that you would get just for the materials, and the same can be said for fully functioning refurbishment computers. They are 3, 4, and 5 times the value of just the parts. So I highly recommend that what you do is that you use these slides for your training or education of people to begin their process. I would be thrilled to see them used all over the world. There is also a conference which you can attend. It's 2 days in the United States, where hundreds of people who have been doing this for years and years and years gather to talk about the successes and how to solve some of the opportunities or problems that they have. If you want to find out more about the Microsoft Registered Refurbisher Program, then here is the URL for that. And if you want to have join a conversation of refurbishers, there's a refurbisher group that you can join. Now, my focus on this first part of this presentation has tried to be very practical. What are things that I can actually do to start on the road of using and reusing computing equipment? And the idea behind that is, if we can reuse the equipment, that is by far the best environmental outcome that we can ask for with this equipment. Now let me talk specifically about the guideline that Project Group 1.1 of the PACE Working Group created. It's called the Guideline on Environmentally Sound Testing, Refurbishment, and Repair of Computing Equipment. And it includes, like I said earlier, it's a 44-page document that includes a lot of information that you can read through and start to understand from many different points of view on what it means to do repair and refurbishment in an environmentally sound way. Talks about a flow chart or a way to think about and process this material so that you get the best result possible from this flow of material. It'll help you sort what is refurbishable versus what is not refurbishable. It'll give you guidance on data security and data destruction. One of the things I think, especially in this world of technology, where so much personal data can be captured on these electronic devices, I think it is incumbent upon all of us to make sure that we are cognizant or aware that there is lots of information that can be on these devices of a personal nature, and we should take care, if we're going to reuse this, to get rid of the old user's information and have a fresh, clean start. There's a guidance on how to handle or label or document these devices and how to pack them and storing them so that you maintain a maximum amount of both economic value but also environmental value. And there's also some guidance for what to do with this equipment, where to get it from, and where it should go, or where you might want it to go once it's been refurbished. My particular program started for full functionality of these devices, so that it is reused, particularly in this context with the Basel Convention. If this material is going to cross a border, we want to make sure that it has full functionality, and it's not just a waste that is being shipped to a different location where it might be easier to deal with. So there are 18 specific recommendations under 3 subheadings. The three subheadings are environmentally sound management, or ESM, refurbishment and the repair process, and the marketing and redeployment of these devices. So it's a good overview. I highly recommend that if you're thinking of going forward with a refurbishment program, either in your area or many of them in your country, that you study this document to get an overview of it, and then look to see what specific pieces of information you need to go forward. Again, this is my information, not so much, I mean, it's interesting, but just so you have it. And actually, that's the end of my presentation. I think what I will do at this point is turn it back to the Secretariat and see if there are any questions, or if we want to do Francesca's presentation.
Good afternoon to all of you. I hope you can hear me well. I have the pleasure to introduce the context of the presentation of today. It is the E-Waste Challenge MOOC, a massive open online course which was launched on the 1st of April, and it is available for 8 weeks with interactive lectures like the one of today, and then later on it will remain available as an e-learning. The MOOC was written and launched by the Basel Convention Secretariat, the Basel Rotterdam and Stockholm Convention Secretariat, KU Leuven, Climate KIC, the World Resources Forum, and the Raw Materials KIC. It is designed for a broad audience. Students will take it as part of their PhD at KU Leuven, and it will be worth 2 ECTS credits, or other also operators, recycling operators, graduate students, and government officials. It is designed for 35 or 40 hours of learning to be taken in 8 weeks, but it can be taken at the pace of each person. It is hosted on the platform of the Climate KIC, which is called the Innovation Primer. It is organized in 5 modules, and the lecture of today is part of Module 3 on methodologies and methods for the sound recycling and refurbishment of computers and e-waste in general. In order to finish the course, it is necessary to write a project, which is called Canvas, and the whole content of the course supports the Canvas. The Canvas is necessary, the project is necessary to obtain the certificate of attendance. The MOOC offers also a learning community. Each nugget, which is a sub-unit of a module, it has a discussion forum connected to it. So join us and attend the MOOC and be part of the solution. And now I pass the floor to Dan for the questions and answers.